Okay, there you are. The first example. Sometimes we give you the instruction, and sometimes you find out the instruction yourself, which method already. Since we don't have any other, so this is going to be the first one. 4.4. Yes, that's it. So this is it. Example, we want to solve. Okay, solve the differential equation. The differential, okay, equation. Number one, give you something to warm up first. Y double prime minus 2y prime equal to the 12x minus 10. You see the equation is non-homogeneous. So what you have to do, you have to solve the homogeneous one first. You find the YC, you come back, you find one particular solution, then YC plus YP is going to be the solution of the equation, okay? So we go for it. First, we are going to solve the homogeneous one. Okay, that's it. Coefficients are constant. So for the characteristic equation, r squared minus 2r equal to 0, solve it. R times r minus 2 equal to 0. So we get two solutions, r1 equal to 0 and r2 equal to 2. Okay, so we have two distinct solutions, and you know what's going to be the general solution. So YC is going to be a C1 e to the 0 plus C2 e to the 2x. So e to the 0 would be 1, so that gives you C1 plus C2 e to the 2x. This is going to be YC, the solution of so-called complementary equation. That's part one. Any question? Part two, you have to find the YP. Yes, what's the question?
I remember last time we said everything equals to 0, but what happens to the 12 minus 10? Does it go away?
In order to solve the differential equation, you have to solve what? Homogeneous one first. Homogeneous one is when you consider the second part to be 0. You find the YC, but you are not done. Okay? So you have to find YP.
Oh.
In order to get the YP, as you can see, the coefficients are constant and the function is R of X is a polynomial. So we can use, okay, and determine a coefficient automatically. So undetermined coefficient, Rx is a polynomial, create a polynomial yourself. Yp equal to is a polynomial of the first degree, make one. It's going to be a1x plus a2. Okay, now check. Check to see if, this is going to be checking one. You check to see if any repetition over here, duplication. You see, you get the a1x plus a2, a constant, and you will see the constant here. So you have to upgrade it. Okay, duplicated, okay, you have duplicated term. Duplicated term is the constant. So this is not going to be a good one. Upgraded by multiplying by x. a1x plus a2 times x. Okay, so this means you are going to have a1x squared plus a2x. To double check, there is no constant term anymore. Yes. You see, when you do the YP and the YC in your particular solution and the YC, you cannot have a sharing. Okay, no term. If you have the sharing, you go back, substitute, everything would be 0. So you see, you have a constant term over here. C1 is a constant term. And you have a constant term here. So there is a duplicated terms because. So what you do, you upgrade the YP. You multiply by x. Check it again. If there is going to be shading again, you multiply by another x. So as you can see, a1x squared, there is no x squared here. a1x, there is no x here. So this is the candidate. And you should be able to do it. If you miss it, when you substitute because of that duplicated case, the term to the left would be 0. The term to the right would be a function. Then you'll be surprised that you cannot continue. So if you cannot continue, the only place that you missed it is that duplicate. Okay, any question? Now go back. You have to go back and substitute yp into the original equation and then solve for A1 and A2. Takes time a little bit. Depends on what you have, okay? So since you want to go and back substitute in this equation, we need to have a y prime and y double prime. So differentiate, okay? So y prime is going to be 2a1x plus a2. That's y prime. Continue, y double prime of b. Differentiate again, that give it 2a1. Go back to the original equation. You see, this is your original equation. And substitute. Substitute this equation because yp is satisfying this equation. Okay, yp double prime is 2a1 minus 2y prime. It's going to be 2 times 2a1x plus a2. It's equal to the 12x minus 10. Simplify this one. It's a 2a1 minus 4a1x minus 2a2. Okay, 2a2 equal to the 12x minus 10. Which one? Yes, 2 times 2 would be 4. Now you see on the other side, you have a polynomial. The way we are going to get it, you know that polynomials are different, only their coefficients. So you organize this one, you write down in the standard form, and let the coefficient of the same monomials to be equal to each other. So this is the way we do it. It's going to be 4a1x plus the constant term is going to be 2a1 minus 2a2. On the other side, you get the 12x minus 10. So you let the coefficient of the monomial of the same power equal to each other. For the x, the coefficient is negative 4a. The coefficient of the x over here is 12. The constant term over here is this one. The constant term to the other side is a negative 10. So this is the way you are going to get two equation to be able to find the unknown. So we get the negative 4a1 equal to 12. And the second one give you 2a1 minus 2a2 equal to the negative 10. That's it. You solve the system and you get a1 and a2. Any question? So this you're just working only with the polynomials. Yes. Okay. Now from the first part, we can find the a1. So the a1 would be negative 3. And we substitute the second one, we get the a2. Okay. In the second one, it's 2a1, 2 times negative 3 minus 2a2 equal to the negative 10. Okay, negative 10, so that gives me negative 6 minus 2a2 equal to the negative 10. So the negative 2a2. You add the 6, that gives me negative 4, so a2 would be 2. Okay, go back, substitute, and get your result. Remember the yp? So the yp was a1 x squared plus a2x. Now you substitute. A1 is negative 3x squared. Okay, negative 3x squared. And A2, 2 plus 2x. This is your particular solution. The general solution of the equation, y equal to the yc plus yp. Okay, we accept it, but if you want to substitute, it's going to be your yc is c1 plus c2 e to the 2x follows by the yp. Negative 3x squared plus 2x. So this is going to be the general solution of the equation. Very nice method. Okay, Mr. Mangili. Yes, what's the question? I substitute in yp. This is the yp. And you have the a2 equal to the 2 and a1 equal to negative 3. You go back and you substitute because the target was to find the yp. Okay, any more question? Yes,
Can you go over the monomial part again?
monomial.
Yeah, you said what the coefficient.
You see, polynomials are going to be the same if their coefficient of the monomial of the same degrees are going to be the same each other. Because the polynomial is different in their coefficient, okay? So what you have over here, we have the x as a monomial. So the coefficient is negative for a1. You compare it with the x on the other side. Their coefficient must be the same. Then the constant, okay? If it's going to be a start with the x squared, you check the x squared first, okay? This is a condition for the polynomial. Two polynomials are the same because the monomials are the same for all of them are x squared, x, okay? So the coefficient must be the same. You get this advantage. If there is a term is missing, you are going to consider to be zero, okay? So if there is not going to be any negative 10 over here, you consider that's a constant term is zero when you want to compare them. Okay, so that is case one. Any question? Let's check another one in the case two that we are going to have. Okay, the case two, maybe you have a combination of a couple of these functions, okay? And then what is going to be the second one? This one takes a little bit more time, but don't worry, we're able to do it. So number two. Number two, you want to solve this equation. Y double prime minus 2y prime minus 3y is equal to the 4x minus 5 plus 6x times e to the 2x. See this one. The difference is, in the case of the yp, you have two types of function. So one of them is a polynomial, the other one is exponential one. When you want to solve the equation, we are going to consider them one by one. I'll show you in a minute, okay? So to start with, you have to solve the homogeneous one first. So y double prime minus 2y prime minus 3y equal to 0. Solve this one first. Okay, characteristic equation, r squared minus 2r minus 3 equal to 0. Factor it. R minus 3 times r plus 1 equal to 0. So we have two solutions. Okay, so solutions are going to be 3 and negative 1. So the general solution yc is going to be c1 e to the 3x plus c2 e to the negative x. So this is going to be your case. Okay, to get the yp, you better divide it in two parts and do it twice. You can do it once, but it takes time. Okay, so what we are going to do is we have to find the yp. Okay, and we bring the rx. R of x is two types of function. You see it's a 4x minus 5 polynomial. And then you have a polynomial times e to the 2x. So we can think about it as yp1 if you like, and the yp2. Do it twice. It's much, much easier. So this means you are going to consider this equation first. Y double prime minus 2y prime minus 3y equal to the 4x minus 5. You find the yp for this, and then you go back and find the yp for the other one. Some people, they do both of them at the same time. They do the missing if the, if the equation is not going to be nice. So we go with this one. You find out what's going to be the yp. Okay, it's a polynomial, so you need to change it to the polynomial of the first degree. So we get the a1x plus okay, a2. You check for the duplication. Okay, checking. You see, this is your yc. Nothing to do with this one. So there is no duplication. Okay, so yp would be a1x plus a2. So we can continue with this one. Any question? So you see your YC are exponential function. So there is nothing in between. So differentiate, you need a Y prime and Y double prime. So in this case, Y prime would be, okay, A1. And the Y double prime would be 0. Okay, go back to this equation and substitute. Okay, so we're going back to this equation, Y double prime, I remind you, equal to the 4x minus 5. If you substitute Y double prime is 0, and this is minus 2 times A1, minus 3Y. It's going to be 3 times Y, A1x plus A2. And this must be equal to the 4x minus 5. Okay, so I substitute the YP, Y prime, Y double prime into the equation. Again, you have to simplify it and let the coefficient to be equal to each other. So this is going to be negative 2A1. You distribute the negative 2A1x minus 3A2 equal to the 4x minus 5. Organize it as a polynomial, negative 3A1x. So the constant term are going to be negative 2A1 minus 3A2. On the other side, we get a 4x minus 5. Let the coefficient of the monomials to be equal to each other. You see, you have this one, and you have this one. Okay, from the first part, we get the negative 3A1 equal to 4. From the second part, we get negative 2A1 minus 3A2 equal to the negative 5. This is going to be a system of equation that give you the two solutions. So from the first part, you get the A1 equal to the negative 4/3. Then you substitute down here, you get the A2. Okay, so that we're going to negative 2A1, negative 4/3, minus 3A2 equal to the negative 5. You have algebra, and so that give you 8/3. 8/3 minus 3A2 equal to the negative 5. Let's move it to the other side and take care of it. Okay. So this is it. It's going to be 8/3, for example, plus 5 equal to the 3A2. 5 times 3, 15. Okay, 15 and 8, that give you 23. So 3A2 would be 23 over 3. So the A2 would be 23/9. So that give you A2 and the A1. So you are going to give us the first one, YP1. Okay, we substitute the YP. Yes, what's the question?
So you have Y P prime equal to A1 and Y prime, Y double prime P equal to 0.
Yes,
How would you like to find it?
I differentiate.
Differentiate what?
This is the YP. This is YP. You differentiate it. Y prime would be A1. If you differentiate again, Y double prime would be 0. Okay, you got it? So coming back, this equation that we have here, so we substitute for the A1 and the A2. What's going to be the result? This we call it YP1, the first one. A1 is a negative 4/3, negative 4/3 x plus 23/9. Okay, this is going to be particular solution corresponds to the polynomial, but you're not done. You have to do it again, but this time for the YP related to the 6x e to the 2x. Okay, are you ready? So I need to find the YP for the second one. So the second equation now is Y double prime again, minus 2Y prime minus 3Y. That we have to consider it with the 6x e to the 2x. Okay, the polynomial is 6x. Then you need a combination a1x plus a2x times e to the 2x. And there is not going to be anything duplicated because in the case of the yc, the power are 3x and a negative 1. Nothing to do with the e to the 2x. Okay, so we design it and we go for it. Okay, so this is it. So we compare them together. So the yp is, I'm going to write on this next page. Okay, so I make the yp this time. Polynomial is the 6x, so the yp, okay, that's it. So the yp would be a1x plus a2 times e to the 2x. And we already checked that. Okay, nothing to do with this, no duplication. You have to differentiate this one now. Yes. Yes, you have a 6x, we change it to the general polynomial. No, you see, 6x is what type of polynomial? Linear. So you have to write a completely linear. Okay, that's right. You may think about that as 6x plus 0. Yeah. So you have to, you change them into the undetermined coefficient over time. Okay, there you are. You have to differentiate it. Okay, you need the yp prime and the y double prime, and this you repeat that procedure again. So go ahead, differentiate it. Product rule, derivative of the first times second, second first. Derivative of the first one would be a1 e to the 2x. Okay, that's the derivative of the first second. Derivative of the second first. Exponential function never changed. The derivative would be 2 times, okay? So it's going to be a1x plus a2, but times it by 2e to the 2x. Okay, you better multiply them together. Simplify it a little bit. a1 e to the 2x, and you just multiply 2a1 x e to the 2x, and plus 2a2 e to the 2x. Okay. Then you have to find the second derivative. So go ahead, find the y double prime. This would give you 2a1 e to the 2x. You have to apply the product rule here. Derivative of the x is 1, derivative of the first times second, second first. So that gives you 2a1 e to the 2x. Derivative of the second times first, the exponential function e to the 2x, we get a 2, 2 times 2, 4. So that would be 4a1x e to the 2x. Okay, I just apply the product rule into the x times e to the 2x. If of the first times second, if of the first is 1, e to the x. If of the second times first is a 2 times e to the x, so 2x, 2 times 2 would be 4. And you continue to differentiate this one. If of e to the x, you have 2, 2 times 2, 4, a2 e to the 2x. Okay, so you can do a little bit of simplification. These two would be, we can add these two that give us 4a1 e to the 2x. Okay, and then the rest. See? Now go back to the equation, substitute, and let coefficient to be equal to each other. The same thing that we did for the others. Okay, going to the equation. What's going to be your equation? Your equation is y double prime minus 2y prime minus 3y, this time equal to the 6x e to the 2x. Now carefully substitute. Y double prime, this is y double prime. So that give you 4a1 e to the 2x plus 4a1x e to the 2x plus 4a2 e to the 2x. That's a y double prime. Minus 2 times y prime. That's your y prime. Okay, I write it down so you know what's going on. 2 times y prime. Your y prime is a1 e to the 2x plus 2a1 x e to the 2x. Okay, plus 2a2 e to the 2x. that is y prime. And eventually y minus 3 times y. 3 times y, this is y. So 3 times y would be 3 times a1x e to the 2x, okay, plus a2 e to the 2x. And this is all is equal to the 6x e to the 2x. As you can see, you can, you can continue or you can divide everything by e to the 2x. Or you can simplify first, then do the things. So a number of these coefficients are going to be simplified, okay? So this is going to be the case. I have to multiply to simplify these terms. 4a1 e to the 2x plus 4a1x e to the 2x plus 4a2 e to the 2x. That's going to be negative 2a1 e to the 2x minus 4a1x e to the 2x, and this is going to be minus 4a2 e to the 2x. And you multiply the 3, negative 3a1x e to the 2x minus 3a2 e to the 2x equal to the 6x e to the 2x. You can combine the like terms carefully and then take care of it. The terms, the like terms is, this is it. So you get 1, and you get a 2 here. That's going to be 3. Okay, you get quite a lot. These are going to be your like terms. So with the A1, this is 4A1. This is a negative 2. Okay, that's a 4A1, and I have an A1 over here. So that give me 2A1. Okay, this 2. This 2 is going to be 2A1. You can drop all the e to the x if you like. Okay. This is going to be the A1. Where is the positive 4? No. You're not going to be like that. We go to that one later. Okay, you talk about this one. That's the one.
Yeah.
But I'm going to check the constant pairs. Okay, that's a 4a2 e to the 2x, and this is a 4a2. Okay, so these two would cancel out. Okay, what else? So the only other thing that we're going to see is going to be minus 3 a1x e to the 2x minus 3 a2 e to the 2x, which is equal to the 6x e to the 2x. Okay, that's the best you can have. You better check it yourself. What's your question? Which one?
Oh, sorry. 4a2 e to the 2x.
You just substitute y double prime here. This is 4a2 e to the 2x. Okay, let me finish it. So what we can do is you can divide by e to the x. You see? So that give you 2a1. Okay, minus 2a1x minus 3a2 equal to the 6x. You see, eventually we get polynomials on it. So as we did it for the other one, it's a 3a1x plus the constant term 2a1 minus 3a2, which is equal to the 6x. It's like 6x plus 0, if you like. So you let the coefficient to be equal to each other. So from the first part, you get 3a1 negative 3a1 equal to the 6. And the second one, 2a1 minus 3a2 equal to the 0. You see, this must be the one. So from the first one, a1 would be negative 2. And you substitute in the second one, So the 2 times the negative 2 minus 3a2 equal to the 0. So that gives you negative 4 minus 3a2 equal to the 0. So a2 is negative 4 tenths. Okay. So you put them together, that gives you the yp. Yes.
So for this one, I have a repeat answer, right? Because the YP1 is that the A1.
No, there is no definitive answer in this one. What is your definitive?
The A1 value is translated to YP1 is also negative 4.
Oh, this coefficient, it doesn't matter. No, the coefficient doesn't matter. So then maybe all of them the same. That's the equation, that's the solution to the equation. Okay, there you are. So we get the yp2. So the yp2 is going to be, remember this is yp2. So we get the a1 of a negative 2. So it's going to be negative 2, negative 2x, okay, minus 4/3 e to the 2x. So finally, your particular solution, yp, is going to be yp1 plus yp2. Remember, for the yp1, you get the negative 4/3 x, negative 4/3 x plus 23/9. And for this new one, we get the negative 2x minus 4/3 e to the 2x. That is the particular solution. And the general solution is yc plus yp. I just pick this one, show you that you got to be patient. The one that you may get on the test is going to be, you break them into parts, okay? But you must know it. More complicated, how to handle it. So it's all polynomials, with nothing to worry about. Okay, any question? So you have some in your book and you have a couple of them in your practice one that we're going to do it again, but try it yourself to see how we're going to handle it, when it is given to you on the test.
You're saying for the test, we wouldn't have to write out the full Y answer at the bottom, we just write that.
If you find the micro
Okay, so we don't have to put it all.
No, you don't have to repeat it again, unless you don't be particular solution we want to find. Otherwise, we know. You don't have to carry all the.
So just don't put a particular solution on the exam and we don't have to worry about it, right?
Why not? Okay. Okay, so this is how we're going to handle these type of problems. Of course, later on, you're going to see this problem can be done with various methods. And the determinant of coefficient is one of them. And eventually, by the end of this chapter, Laplace transform is another technique that we can do. When the coefficients are constant, you have many choices to take care of this equation. But we have to go through all of them, okay, to get it through. Okay, so this is going to be one version. Any questions? Now, the second version is we would like to make sure that you understand when it's higher order, okay, be able to at least write down the yp points. So we give you another question. In this question, you're not going to require to find the yp for us. So we'd like you to just give us the form of the yp, okay? So I give you one, so you know that when it's going to be given, it's an expression, instruction, don't be confused. We are going to emphasize for this that you don't have to find the coefficients, okay? You just check, you see this is how, and there is a series of problems in your book, the same thing. Example. You see, this is the second format. The format is determine. Okay, determine is suitable. A nice one. Form for yp or yp of x. It's the same thing. Particular solution. If the method, okay, if the method of the one that we talked about and determinant coefficient undetermined. Coefficient. Okay, undetermined coefficient is to be used. Okay, suppose you want to do it, but we just want you to find the form. We don't want you to solve it. Okay, they are going to give you this instruction that do not find, okay, the coefficient. The coefficient, if you like, in YP. Just give us the form. Okay. So this is going to be all sort of functions that we're going to have. In practice, they don't use the Tx, they use T for temperature. Okay, so I just use the same thing. But you can change it to the X if you don't like it. So the first one, suppose this is your equation, y double prime plus 2y prime plus 2y equal to 3e to the negative t plus 2e to the negative t cosine of t plus 4e to the negative t, okay, t squared sine t. You see, this is the given equation. Would like to write the yp only for us. You know that you have to solve for yc because of the duplication. So you have to solve for the yc first. Okay. So the solution, get the yc, y double prime, 2y prime, 2y equal to the 0. Otherwise, you won't be able to check to see if there's going to be any duplication. Okay, so characteristic equation r squared 2r plus 2 equal to the 0. You cannot factor it, so use delta because the solution is going to be complex. Okay, use quadratic formula. So r is equal to negative 2 plus or minus the square root of negative 2 squared b squared minus 4ac 4 times 1 times 2 divided by 2a, which is going to be 2. Simplify inside the radical. It's a negative 2 plus or minus the square root of 4 minus 8. And that's a 2. 4 minus 8 would be negative 4, and you're able to use the complex numbers. Okay, radical negative 4 over 2. So radical negative 4 would be 4i squared. So r would be negative 2 plus or minus 2i over 2. Okay, negative 4, you change it to 4i squared, so that gives 2i. So you break it to get a complex format, plus or minus 2 over 2 times i. Simplify by 2, negative 1 plus or minus I are going to be your solutions. So you pick one of them, you identify the alpha and the beta, and you write the yc, remember? So r, I picked the r to be negative 1 plus I. So compare it with the alpha plus beta I. So your alpha would be negative 1. Your beta would be 1. Identify your solutions. Yc equal to, remember, e to the alpha x cosine of the beta x, and the other one. Since the variable is t, you go with the t. So yc would be c1 e to the alpha negative t cosine of t plus c2 e to the negative t sine of t. So this is going to be your yc. You get this one today. Okay, now what is going to be your YP in this case? We have three cases. Okay, we can compare them together. This is going to be your R of X. You see, you want to find the YP. So R of X or R of T in this case is 3e to the negative t plus 2e to the negative t cosine of t plus 4 t squared e to the negative t sine of t. This is going to be the case that we have. So you have a kind of three types of function. Okay, over here, we have the first one is this one. Okay, then this is going to be the second one. And this is the third one. The first one is exponential function. So that's it. Coefficient is 3. So we get the first one. So that's going to be the YP equal to. For the first one, I need just a coefficient. So I change it to the A1, e to the negative t. That's the first one. We check to see if there is anything duplicated. So if you compare them together, there is no duplicated term. Because the term are e to the t cosine t. You need e to the negative t by itself. So this is done. This is going to be for the first one. Any question? Next, cosine. You know that for the cosine, we get a combination of cosine and sine. The coefficient is just a constant. So for the second one, this is the second one. For the second one, the polynomial is a constant. So I need to have a constant. I already going to use the A1. So I use the A2. It's going to be A2, e to the negative 2 cosine. And anytime you use the cosine and sine, you have to repeat it. Plus A3. Okay? Plus A3 e to the negative t sine of t. So this would be for the second one. Okay, because the function is cosine. When we get a cosine, we write the combination of sine and the cosine. You check to see if it's going to be anything duplicated. You see e to the negative cosine, e to the negative cosine. So there is a duplicated term. You have to find the multiply by x. In this case, we multiply by t because the variable is t. T. We upgraded it. Any question? So that's the second one. Yes.
So we only do it once, even though the e to the negative t sine of t also matches?
No, no, no. That's something different. This one, oh, yeah, when you multiply, it automatically multiply by itself.
Oh, okay. Yeah.
You see, I put the parentheses around it. When you put the parentheses, you multiply both of them.
Yeah, it's just, I was thinking that because it shows up again and we would do a t squared instead of just,
Oh, no, no, that's
Yeah.
something different.
that makes sense.
That's something different. You only made that one. Yes.
I don't understand why anytime between y you multiply sometimes by t, sometimes by x, t squared. Like how do you determine that?
What you need, you have to check to see what you need. So in this case, the duplicated term is e to the negative t cosine t. So if you multiply by t, that would be t e to the negative t cosine. The duplication would be removed. It doesn't matter. You multiply both of them. There is a parenthesis here. You see, you do both of them at the same time. Okay? You see, you don't need to multiply by t squared. T is doing it.
Why is that one e to the negative t not included?
Because it's different. You see, it's a three function. See, look at this. The YP is, look at all of them. 1, 2, 3. Now, three different functions. So you have to do as well. 3 YP, 1 by 1. The first one. You change it to the one. Second one, 4 times. A combination of sine and cosine. Doesn't matter, doesn't have it. But when you write it down, this is exactly what you have to do. You have to upgrade it. Okay. Now change it to the t e to the t cosine. So I'm done. I don't need to multiply by t. You can multiply by any power you like. And you have to check to see which one is necessary. Yes.
So for this one, we're just what the YP that you're writing right now, so you're gonna find out answer. Can you just put it for the
Of
final
course.
solution?
If you want to do it yourself, go ahead. Okay, good luck. You are not done. You have one more.
Can we do it for extra credit?
Which one? Okay, you have to do this one. Again, you get the sign. So we have to do a sign and a cosine again. What's the coefficient? T is good. So it is quadratic expression. So you have to give us a complete quadratic expression in terms of the t for the sign and the cosine. Okay, so that's it. What's gonna be this one? Plus, that's a nice example. You get all the possibilities. Plus, now the third one is 4t squared. Give us a quadratic expression, which is, I use the A3 over here. Quadratic expression, A3t plus, sorry, A4t plus A5t squared. That's a complete quadratic expression, a polynomial of a second degree.
Why did you repeat the A3?
Yeah.
Why would you just go to A4?
I'm sorry. A4, you are right. A4, 5, 6, yeah? Oh, you made me in trouble. So it's going to be 5, 6. Can you see it? I have to rewrite it. Okay, do it again. So this is it. What was it? 3, 4, 5, and 6. T squared, e to the negative t sine t. And you have to repeat it again. Okay, you have to repeat it again to get the cosine. So it's going to be plus, continue.
A7.
That's it, yes. A7, A8. Okay, A8, that's it. And that's it, that give you A9. A9, T squared. E to the negative T, cosine of T here. Okay? No, you have to check it.
Would that all be in parentheses together? Because
Which one?
part of it, the,
Yeah, eventually.
okay,
Okay, now check to see if the anything is going to be repeated. This is the YC. So you have one repetition here, you see? A constant e to the negative t. A constant e to the negative sine t. So you have to upgrade it. You upgrade it into what? You get a bracket here, and you multiply by t. If you multiply by t, you'll be safe. So this is going to be the YP, okay, for this type of problem. This is the problem from your book. Check it. One of the problem in your book, I think it's the number 22 in that section 4.3 that you have. Okay, so it's not difficult. We just wanted to give you different scenario, if you like, so that you understand. So that's going to be the case. So that duplication is the one that you should be able, you should remove it. Otherwise, if you want to do it, then you substitute everything with the 0. Because this is the solution, you see. The solution of the YC means if you substitute in the left part of the equation, make it 0. Yes. Only YC. No, I didn't. Because we already done matrix. So there is not going to be anything. You see, you consider each one of them one. They are separated from.
so then after you're done with all this, you would put y equals YC.
No, they ask only for the YP.
Oh, yeah, okay.
Okay, because we didn't solve it.
Would you mark this down if we put y equals YC equals?
Oh, I put the question mark for it. Okay, anyone, any question? So, let's do another one. So let's do at least one more. So expect a couple of them. Your one question is going to be two parts of this quantity over here. Let's try another one. Okay. So the other one is again. So that's a number two. Number two, again, you have to do the y double prime plus 4y is equal to the t squared sine of the 2t. Okay, plus 6t plus 7 cosine of the 2t. Okay, this must be straightforward. Again, solve the YC, because to get the YC, so the solution is going to be, we are going to solve y double prime plus 4y equal to 0. Get r squared plus 4 equal to 0. Okay, so r squared equal to the -4, which is the 4i squared. So your r would be positive -2i. Okay, pick one of them, r as r equal to the 2i, which is the same as the 0 plus 2i. If you compare it with your alpha, beta, I, so your alpha would be 0 and your beta would be 2. Okay, so your solutions for the YC, C1 e to the alpha 0, cosine of the beta x or the beta t in this case, 2t plus C2 e to the 0 sine of the 2t. E to the 0 is 1. So the YC is equal to the C1 cosine of the 2t plus C2 sine of the 2t. So this is what you get over here. Any question? Now bring the R of X, compare it together, and get your result. This is it. So we are interested in the YP. With the case that the R of T, if you like, is T squared sine of the 2T plus 6T plus 7 cosine of the 2T. You get this one? Compare them together and write the final answer. There is a point about when you write this one. That's why I picked this one. Let's see. You see, you have a t squared sine of the 2t. Okay, so you have to write a quadratic one. Okay, at the same time, quadratic one would cover the sine and the cosine. So this is it. So the YP is going to be equal to. It's going to be equal to the we get the first part. Okay, the first part start with the A1, A2T plus A3T squared. Okay, that would be sine of the 2T. And at the same time, since it's sine, you have to get the cosine as well. Okay, so it's going to be continue. A4. Okay, A5T plus A6T squared. That gives you cosine of the 2T.
Why are we replacing the 2 with the same coefficient as well?
Which one?
The sine of the 2t, wouldn't you replace that 2?
You cannot go inside the sine. That's a sine of the 2t. It's a sine function. Okay, you're just changing the polynomials. Okay, not the same. Now you check to see if there is going to be any duplication. You see, you have a cosine of t here. Okay, that's it. We get the cosine of t, so we have to upgrade it. So you upgrade it by multiplying by t. Okay, so you can multiply both of them by t over here. Okay, so this is going to be T. Okay. So that would be T, and that would be enough because that make it, you raise the power, so there is not going to be any duplication to go. So that would be the first one that you created over here. Okay, to get the numbers, you see, if you go with the second one, in the case of the second one, is a kind of I write it down, then I explain it for you. What would happen to the second one? You see, if you go with the second one, because this is going to be a polynomial, 60 plus 7. So when you change it, let me write it down, then I explain. If you go with the second part, in the second part, you have a first degree polynomial. So we change it. So we change it into what? Let's do something. 6. We go with the 6 of 7. So it's going to be A7T, if you like, plus A8. Okay, that would be the cosine of the 2T plus, you can continue. You get the A9T plus A10, if you like. That would be the sine of the 2T. Okay, in this case, again, you have a duplication over here. So then you have to multiply this one by T as well. Okay. You have to multiply this one by T again. So that would be T squared in the T, and then you'll be done. But the point about this one is, you see, if you multiply the T inside, that give you kind of, when you want to do it, you don't want to do this one. But when you want to do it, there are going to be some common coefficient. So basically, you don't need the second part at all. Okay, you can go with the first part right away. That would be your solution. Because when you write the constant, you see, when you write the constant, look at this one. If you multiply the T inside, you see, and you multiply the sine of the 2T. So this part of the T and the T squared, when you combine them together, you can factor it out. So the second one would be irrelevant. You can stay with the first one and find your coefficient. Okay, these are the ones that, if you don't want to do it, you want to find the YP. But if you want to do it, these are some of those things that you think about it when you want, when you apply it. Because it's a constant, it's up to you. It's A3. When you factor it out, you will get a couple of these together. Okay, A2 plus A8 plus A6, you remove all of them. You got a B1 and you can figure. Okay, but this is the point about this type of problem. It would be good when you want to do it. It's good to know. Yes.
Could you have done that with the problem before this too?
What's that?
Could you have done this with the problem before this too? Because the problem before this also had a lot of competing ones.
Not like this one.
Not like this. Okay.
But this is just a choice.
If-
Okay, that's it, because that would take science. You have 4 on your practice one, you can check it on Wednesday. You have a break, you come back and you take the last method. And it's a variation of from very nice method. Then you have an option. You may like that one more. And you may be able to do it, but we're going to ask you for this test if you want to check. But in future, it's up to you. Which one is going to be better. Yes. Yeah. Doesn't make sense, so. Doesn't make sense. You have the G by H of X and the N. Then we make them begin.
Yeah.
It's the same thing on the quiz. When you pointed to C, it did not give me a 4 with C, but I still did the same thing. Oh, that's why it goes by the same thing on the test.
Okay, I can take this point out. I give you the same amount of the point. I give you 7 out of 10. Over here, we give you 3 out of the.
But why is this wrong?
It's wrong. Doesn't make sense, doesn't make sense at all.
It's the integral of both,
I know, so how you get this one?
because this, these are the common stuff between the both. of them.
Doesn't make sense, I told you, some of the people they do it doesn't make sense. You have to introduce a function. Yes. Have you done calculus three?
I did, that's how
You
we
did
did it,
calculus three, Dr. Thing?
yeah,
I'm
that's how we
surprised,
did it,
I'm surprised. What an instructor?
Jenna Sandberg.
Yeah, I was taught that method too.
No, no, no. You see, the logic of your proof makes sense. You need to introduce a function.
Can you show me how to do that?
Check your notes, check my solution.
And then,
How's he? He's having.
You see, you didn't,
You
I know
didn't-
that Gino how to do it. Probably the Gino introduced the function first.
No, what he wants us to do is to do the integral of one of them, and then you're gonna call this your XCI. And then you know if you take the derivative of that with respect to y, it has to equal this. If you can kind of set them equal and like,
Look at this, my big one. That's the solution.
okay, wait, so that's the ability for the other.
Yeah.
To the graph, I did,
Yeah.
So I.
Read the rest.
Those two,
Yes, read completely this one.
is it the FX, the Y? Gee, I have the same thing.
You don't have the same thing. If you read it again, I'll give you zero value. It's not the same.
Why are you threatening more?
No, I don't threaten you. You just read it. You see, you have to include the function. This function of this problem, the function,
I'm not understanding, what do you mean by a function?
read this one.
Is it the FXY?
Yes. You have to explain. Good, listen to me. You have to explain your method.
You gave me a right answer on that.
No, I didn't give you, I gave it 3 out of 4.
Yes, you told me proceed, you
No,
circled
no,
it.
no.
I assumed it's right.
It was for C as well.
You didn't mark it with this, so I
Listen
didn't.
to me. You want to understand, learn something on that.
I'm trying to get a better grade.
No, no grade. And understand. You take your solution to your, anybody else. Take it to whatever it is. You see, everything that's explained. You have done calculus. You know the concept of the force?
Yeah, I think so.
Yeah,
That's exactly what we do in
that's what we
calculus.
can do. Because it goes like, we tend to. Which. So whenever we send out other email, I think that's when we go. What we get sent out.
Right.
You know, so they're not like-
I know that, but there is the thing,
right,
why you do this type of operation.
Okay, so for, what do you mean, this one? Why did I do this?
You didn't check it.
Can you
Ask you to check that this is estimation.
So, show me how to do that.
Yeah, no, that's why.
Oh,
Anything else? Nope. Don't be angry, I can give you 100 right away. I give you an 8.
well, they postponed it, the quiz, I wouldn't have done the same mistake.
You just repeat it again.
I did the same thing on the homework.
So it's right,
where,
it's right. You just take this one, to math learning such as thing.
There's different, solving different equations with constant coefficients.
Is it okay if I go to
Yes, why not?
Can I do it after pasta?
Yeah, why not?
And this, finding a p value, explaining why p was started, but, plus that happens where, not changing, and then didn't do any other, extend always.
So, you said that because these two are the same, we just don't need to include the last part, right? We would need to? Okay,
Even if you include it, don't forget.
yeah, and then if we go back to this one, we finish up with this. And everything in this is included in this part, so would we be allowed to just not include?
No, that's what.
Is it? Because we have A2, e to the negative t.
No, you said this type of thing will happen when you want to find it.
Oh, okay.
We just ask you to find the YP.
Yeah, so when it's
Just give
something
them
basic, then just leave it all there. But if we're trying to simplify it to actually answer the question, something. Okay, that makes sense. Thank you.
There's something like.
Which you have for the first one real quick? That's your solution that you had for the first.
Why you just get so many? Why you just get so many?
I don't know. I've never been good at taking tests, so I always get like. I can memorize like a formula or something like that, but when it comes to like all the different cases and how to apply it, it gets like mixed up in my head. I don't know how to explain it.
If you need more time, you can give me more time.
Oh, so for this one, you swap those.
Yeah, it's a separate event.
Oh, okay. Okay, that's a lot more simple than what I was turning it into. And then this is the one where you put it into the secret while. Okay, that makes a lot more sense.
Oh, yeah.
Yeah, and you're gonna post, you already posted that online and
How
everything.
about it?
Okay.
I don't think they want to. Whenever I get first on the fire. It just. Like, so where you guys live now? The one problem that wrong with this.
Okay, are you ready? We can do this. Okay, variation for it. Now, you see some of you maybe, the way we grade the paper, you see, we graded for, this is your last course at the college. So you should be writing, everything precisely really, to make sense, okay? I spent so much time to read your solution really. That's the one, I enjoyed it. But we would like it to be precise, okay? So if any question, it's not the case that I don't like everybody to get an A in this course. But I've been teaching this type of courses for more than whatever you think about it. Okay? And so this is the way we do it. This is the way we do it at the university. Okay? You got to be precise. If you are going to be in CSPSM for each course, you are going to be given grade for, you have to write something like 2,500 words. Write it down precisely. In some discipline, they write an essay. But in mathematics, you have to be precise when you write your logic. That's the one. Okay, I care about it. Otherwise, I can just write, read the solution and stuff like that. No, I enjoy your writing really. When you write, I'm gonna let you know it. Okay. And if you improve it later on, I give it back. I give back your point because you listen to me. Okay, that's gonna be one. I give it back. Okay, I learned this. Okay, I have had great teachers really. And that's the way I appreciate it. At any level that I did my graduation, if you just study a little bit more, then if I name those great people here in that. So I named quite a lot from them. Okay, so this is the way I care. Otherwise, I can give you all of them. So that's going to be one. So don't be upset. That's one. Okay, so let's go with this last one. Remember the method that we did as unique. You don't like it. This is going to be quite wide to be able to find it. And there are many restrictions for this method. The main restriction is coefficient that's the constant. That's one. The other one restriction is on x. You can only use sine, cosine, e to the t. If somebody give you tangent x, it's a very good one. If somebody give you secant x, very good. You can't do it. Okay, that's why you need this new method. This method is going to be called and the variation of the parameter matrix. This method is going to be used here and later on again. Yes.
Can you repeat that last half again? Sorry, I only got the first part. The method.
You see, the first method that we did, there are four restrictions. The first one, coefficient that's the constant. The other constraint are going to be R of x, can be only for the nominal exponential function, sine cos. So if you replace the term to the right by secant x, I can't do it. Or the tangent x, I can't do it. And many cases. So this method that we're going to learn, no restriction. You can do it. The only restriction is there are a couple of tricky integral to find, okay? But otherwise, it's a nice one. So this is the last method. I'll just give you the name. It's variation of parameter 4.6. Okay, 4.6. We give you one problem on this one, on this quiz and your next test. In future, when we solve the system of the equations, we need this method over there. Okay, so that is 4.6. The name of the method is variation of parameter. You must know the name. Variation of parameter.
You can skip 4.5.
Oh, sorry, it's 4.9. Okay. 4.7. Okay, 4.6, 4.6. It's a 4.6. Yes, we are not going to talk about the 4.5. It's again of another method to take care of this. It's nice if you are interested in linear algebra, okay? But we just, you know, because we are going to bring the Laplace transform in future with too many methods already. That's one. Okay, variation of parameters. Okay, parameters method. Be patient. There is a formula. I would like to prove it for you. Then you memorize the formula and you're done. Now, as we talk about it, the restrictions are going to be out. So the variation. Again, we use this method to get the YP. Variation of parameter. Okay, variation of parameters method. Method can be applied or can be used to find a particular solution, YP. Particular solution, YP, of course, of a non-homogeneous, okay, non-homogeneous linear equation. Linear equation, as usual. This is a look at the form of the equation. It's a general equation, y double prime, px y prime, qx y equal to the r of x. You see, no restriction. Coefficient can be anything you like, constant or non-constant, and the Rx, again, anything you like. Now, how are we going to do this method works? For this method, again, we have to have the AC, YC. Okay, suppose there is a method that we're able to solve. So suppose to find the YC, YC would be C1 Y1 plus C2 Y2. Okay, this is the general solution as usual. The general solution of what? Of this homogeneous equation, of the complementary homogeneous equation, okay? Homogeneous equation. I need these two equations together, so I'm going to call this one number 2. Okay, so the equation is y double prime plus px y prime plus qxy equal to the 0. So this would be equation number 2. So suppose somehow we solve this equation and we get the yc. Now, you see why we call this method variation of the parameter is, you see these two parameters here, C1 and the C2. So what we would like to do is, would like to change this C1 and the C2 into two functions. We call it U1 and U2. And we force the result to be our YP. That's going to be the method that we're going to do. Okay, so our question is this. This method is very popular. It's used some other places too. So the question is going to be, can two functions, okay, two functions, U1, they are standard, you have to follow this notation, okay? U1 and U2. U1 and U2, okay, be found so that, should we get this one? So that YP will be of this form. YP equal to U1 times Y1 plus U2 times Y2. We change the parameters C1 and the C2 to the U1 and U2. Okay, can two functions U1 and U2 be found so that this is going to be the particular solution is a solution of that non-homogeneous equation. Okay, it's going to be a particular solution, of course. I have to write it down. A particular solution of the equation number 1. The equation number 1. Okay, so this is the plan. The plan is we change the C1 and the C2, and we'd like to force this function to be over YP. So suppose we can do it, okay? If this is going to be a solution to your equation, it must satisfy the equation. So differentiate it. Find the derivative. Note that. So I rewrite it to see which function I'm going to work with. So this is the YP, this is the suggestion. Okay, this is the suggestion. Differentiate it carefully. Remember, they are all function of X. What's going to be YP prime? Y prime, product group. If of the first, second, first, U1 prime times Y1 plus Y1 prime times U1. That's the first one. Second one. What's going to be the second one? U2, I put in seconds, U2 prime Y2 plus U2 Y2 prime. Okay, that's going to be Y prime. We should be able to, okay, so that's going to be YP. We cannot simplify, that's a YP. In order to substitute the equation, you need to differentiate it again. You need to find the Y double prime, okay? So the next step is going to be, what is going to be Y double prime? Remember the unknown that we have? The unknown is going to be U1 and U2. If you go and substitute Y prime so far, we have the U1 prime, U2 prime, etc. If you want to find the Y double prime, you see, if you want to find the Y double prime, so you have to differentiate this one again, okay? if you, let me just put something. So if you differentiate it again, you see this u1 prime would be changed into the u1 double prime and v2 double prime. And then you go back and substitute the result of the equation, but again, a second is going to be an equation of a second order. That make it difficult for us. So what we have to do is, you are going to do just a modification. We do a modification of this formula. You see, I'm going to put these primes u1 and u2 together first. You see, I'm going to rewrite this one as, I keep the y prime u1 here, and then I keep, I keep this one, u2 y2 prime. See what's going to be the leftover? The leftover is the one that's caused the difficulty. It's going to be u1 prime y1 plus u2 prime y2. Okay, it's the same thing, but I group them together. Remember, it's a plan that you're going to have to find the u1 and u2. Now, in order to make it easier to be able to continue, in order to avoid to get the u1 double prime, we impose one condition here right away. The condition that we're going to impose is, we would like to find the u1 and the u2 so that this quantity over here be equal to the 0. We add this is up to us, okay? So we are going to suppose, why it would be useful because we can do it. Suppose u1 prime y1 plus u2 prime y2 to be equal to the 0. So we continue the solution of the problem with this additional condition. That will help us. Why? Because this would be 0, and then your y prime would be something that will be able to handle it. So y prime of p would be now y1 prime u1 plus u2 y2 prime. So now this is easy to differentiate. We avoid the u double prime. So differentiate it to get the y double prime. If you get the y double prime of p equal to, again, the product rule. So that give you y1 double prime. That's fine because we have the y1 times u1 plus y1 prime u1 prime. Differentiate the second one. That give you u2 prime y2 prime plus u2 y2 double prime. Okay, so as you can see, I get the y1 double prime and y2 double prime, which is going to be fine. So this is going to be y double prime. Now go back to the equation. We want the yp to be a particular solution of the equation. You are going to substitute in the equation number 1. You see, look at this equation number 1. If you substitute here, then that gives you the formula that we are looking for. Okay, so I'm going to substitute. You see, before I go to the next page, this is y. This is y prime. This is y double prime. Substitute all these three quantities into this equation, y1. Let's see. So a substitute, going to the equation number 1. What is the equation number 1? Equation number 1 is this one, y double prime, px y prime, plus qx y equal to the rx. Substitute. I substitute what I have. I substitute for y double prime first, and this is what we got. u1 prime y1, it's algebra that we have to do it. u1 y1 double prime plus u2 prime y2 prime plus u2 y2 double prime. This is if you substitute for y double prime plus px times y prime. This is y prime. u1 y1 prime plus u2 y2 prime. Okay, that's a px plus qx times y. What is y? u1, y1, u2, y2 equal to the rx. You see, if you substitute, you will get all these in one format. Now, if you do a bit of algebra, the factoring, the common factor, you put it together. You see, this is going to be the case. So what I'm going to do is, I'm going to consider this one. See, look at this one, u1. Then I get the u1 here, and I get the u1 here. I'm going to factor out the u1 of all those u1 out. So that give me y1 double prime plus px y1 prime plus, okay, plus qx y1. What is this one? 0. Very good, because the y1 is the solution of a homogeneous equation. You continue, you do the same thing to the y2. y2. You take the y2s. Look at this one. Where is the y2? 1, 2, 3. So that give you the same. So that give you y2 double prime. Px y2 prime plus qx y2. Again, this is 0. Because the solution of the homogeneous one. What is the leftover? You see it's going to be plus. The leftover, look at this one. The leftover would be what? The leftover would be u1, y1, okay, u1 prime, y1 plus u2 prime, y2 prime. Okay, so this is going to be the one. So I have u1 prime, y1 plus u2 prime, y2 prime, and equal to the R of x. You see, as we talk about it, this is 0. This is 0. Because they are the solution of the homogeneous, okay, homogeneous equation. So this means the leftover must be equal to each other. So the leftover is this one, u1 prime. This must be y1 prime, okay? We go back and this is must be prime. So we get u1 prime and y1 prime plus u2 prime, y2 prime equal to the Rx. You see, this is one equation. And remember, there was another one that we assumed at the beginning that we had. So therefore, this is going to be a system that give you the formula that we have to memorize. We are getting to that one. So you have two equations now. The one that we assume in the meantime, u1 prime y1 plus u2 prime y2 equal to the 0. And the one that we just got here, u1 prime y1 prime u2 prime y2 prime equal to the Rx. This is a system of two equations to variables. You can solve it. You can solve it for y1 prime and the y2 prime. You can use addition method, okay, to get this one. You know, you can multiply to remove one of these u1 prime and u2 prime. So if you solve the system, this is going to be the solution. u1 prime would be equal to, you get the negative y2 times Rx. Okay, the bottom one would be the Wronskian of these two. So that's going to be u1 prime, u2 prime. u2 prime would be y1 of Rx, y1 times Rx over the Wronskian here. So u1 prime. So u1 is, these are the ones that you have to memorize. u1 would be negative y2 times R of x divided by the Wronskian, and then dx and the U2 would be integral of y1 Rx divided by the Wronskian dx. You see? If you go back, now we have a particular solution. Remember, yp equal to what? Yp is equal to the u1 y1 plus u2 y2. This gives you the particular solution of your equation. I have to introduce w. Remember w the Wronskian? It's going to be y1 y2 prime minus y1 prime y2. I just prove it so that you know it, how this formula is okay. It can be computed. So the problem would be given to you. You have to identify the R1, Y1, and the Y2. Your difficulty is this R of X. Remember, look at the equation that I give you. Is Y double prime plus. The coefficient of the Y double prime is 1. So you have to make sure that when you pick the Rx, if it's not going to be the 1, you divide it. Otherwise, this integral would be impossible to find. If you cannot find this last part, the integral, in that case, probably you missed it. Okay, look at the Rx. You can pick the Rx, the term on the other side, if this coefficient is 1. So if this coefficient is not 1, divide it first. Then you pick the Rx, you'll be able to do it. This is called the variation of the parameter method. Okay, so basically we make it short. You get the Yp, you introduce this formula. U1 Y1 plus U2 Y2. Then you have to find the U1 and the U2. This is your formula. U1 and the U2. Make sure that you get it right. Just substitute to get the result. But the integral can be tricky because in that case you are going to have a secant, a tangent, okay, a couple of integration by parts. So they are going to be, involved. It's very nice. Yes.
How did you get U prime or V1 prime and V2 prime?
I just solved that system.
Oh,
You can use addition method to solve it. You see? You see, you have to make the coefficient to be equal to each other. So you have to multiply the first one by negative y1 prime, the second one by y. It's a system of two equations to get it. I just want to make sure to get enough time to give you an example. Okay, that's it. That's variation of parameters. A very nice method. We are going to use it when we want to solve a system of the differential equation. There's going to be one case that we have two options. Again, linear algebra or this one. So we put them together at the end. Okay, so let's do an example to see how we're going to operate. So no restriction on this one. That's it. But the only thing is you should be able to find the y1 and the y3 yourself. So there are two possibilities. If the coefficients are not going to be constant, somehow they are going to give you those two solutions to be able to do. And this is going to be the candidate. Okay, so make sure that you memorize this formula and write it down correctly. When you want, I repeat it again. When you want to use the R of X, make sure that the coefficient of the Y double prime is 1. Okay, if it's anything else, because the famous equation that we're going to have, we have Euler equation, Cauchy equation. In future, we give you the method to solve it, but for this quiz, you don't have it, so we bring it up down for you. So there are always the coefficients. Okay, you have to take care of it. Otherwise, it's very standard one. Okay, let's check to see if we can do a couple of them. There are a couple of famous ones with the secant, with the tangent. Okay, let's start with this one. So find, that's it. Sometimes they say find the solution, or just, let's say, find the solution of, find the general solution. Solution of this equation, okay, of the equation. Let's go with the first one. They are very famous one, and you have some nice one on your, okay, on your practice one. Y double prime plus y equal to the 1 over sine x. That's it. You see, the coefficient are constant. And you cannot use the undetermined coefficient to do it. But on the other side, it's 1 over sum. It's cosecant. It's not the sum. Okay, so this will tell you that in order to get the YP, you have to use the variation of the parameter matrix. Okay, so check the homogeneous one first. Y double prime plus y equal to the 0. So that give r squared plus 1 equal to the 0. Solve the equation. R squared equal to the -1 is I squared. So R would be positive -1. Okay, take R equal to the I, which is 0 plus I. So that give you alpha plus beta I. Alpha would be 0, beta would be 1. So your general solution, YC equal to the C1 e to the 0, okay, cosine of x plus C2 e to the 0 sine of x. E to the 0 is 1, so YC would be C1 cosine of x plus C2 sine of x. This is the general solution. Any question? Now you want to find the YP. But your R of x is, you see, the question is YP. You check R of x. Rx, the coefficient is 1, so the R of x is 1 over sine. So you cannot use the undetermined coefficient. You must use the variation of parameter matrix, okay? So the variation of the parameters coefficient, it's just for your information, you go ahead. Must be used, or can be used. Can be used. So pick your choices. That's it. Pick the y1. It doesn't matter which one is it. I pick the y1 to be cosine x. Pick the y2 to be equal to the sine x. And you already checked the rx equal to the 1 over sine x. What is the plan? Yp is equal to, remember, u1, y1, I repeat it, u1, y1, u2, y2. Okay, so you have to find the u1 and the u2. Remind yourself, u1 is equal to this. Not bad to repeat the formula. y2 r of x Wronskian dx u2. It's easy to remember this one. When it's 1, it's 2, the other way around. So that would be y1 rx Wronskian dx. So this is your tool. Go and prepare it. You get the Wronskian first. So we need the derivative of the y1 prime, y2 prime. Okay, y1 is cosine x. So y1 prime is negative sine. Y2 is sine x. Y2 prime is cosine x. Get the Wronskian? The Wronskian is y1, y2 prime, y1 prime, y2. Substitute y1 cosine x, y2 prime cosine x, minus y1 prime negative sine. Okay, y2 sine. What's going to be the result? 1. Because the W is going to be cosine squared of x plus sine square of x, which is 1. Nice. Wronskian is 1. Any question? Go for the U1. This is your formula. U1. Substitute, simplify. So going for U1. U1 is equal to integral of negative, okay, negative y2. What's a y2? Y2 is sine x. So that gives me negative sine x. Negative sine x times r of x. What is r of x? 1 over sine x. Wronskian 1 dx. Sine and sine will cancel out. You get the integral of negative dx. You know that this would be negative x. No constant c. Remember, it's a particular solution. It's not the general solution. So u1 equal to the negative x. That's a u1. Any question? So just nicely substitute. Go for the u2. u2 equal to integral of u2, this is your formula. y1 cosine of x times rx 1 over sine x. Wronskian of 1 dx. It would be integral of a cosine of x over sine of x dx. What's this integral?
Sine to negative 2. To the power negative 2. Negative sine to the power negative 2, right?
Repeat again?
Negative sine to the power negative 2, right?
No. What is cosine over tan?
It'd be u sub, right?
No,
What's Ellen? What's sine or something?
that's it.
Ellen.
U prime u.
Yeah.
If of a sine is cosine, is on the top. So the ln of the bottom. Okay, u prime u. This is sine, derivative of a sine is cosine. So it's going to be ln of the absolute value of sine, or we can consider sine to be positive, whatever. Okay, ln of the sine x or the absolute value of sine x. Remember, no constant c. It's a particular solution. Any question? So we have the u1 and the u2. You are not done. You have to go back and remember the formula. This is it, yp. u1, y1, u2, y2. You have to multiply it, simplify it. Okay. It's not the case that you write yc equal to the yp plus yc. No, you have to find the yp. Okay, are you ready? So remember the u1 is a negative x and this is ln. Go and find the yp. So that's it. Yp is u1, y1, u2, y2. Substitute. What is u1? u1 was cosine, yes? So that's a cosine x. What is the u1? I'm sorry. Negative x. I'm sorry. So that gives me negative x. Negative x times y1 cosine x. u2. u2 was ln of a sine times the y2, which is sine. So it's going to be plus sine x ln of the sine x, or the absolute value. So this would be the yp. Sometimes you may be able to simplify, not that this one. Okay, so now we can say that the solution is y equal to the yc plus yp. And then we got. Okay, it's very nice method. Okay, and the formula is going to be not difficult to handle. Okay, so this is the first one. Any question? Now, you see this problem For the YC, the coefficient was constant, you'll be able to find it. And sometimes if the coefficient is going to be not going to be constant, you can use this method. But somehow they have to tell you the Y1 and the Y2. So this is another version. Okay, what is this version? This is the one that eventually you will do it. We are going to call it Euler equation. But for the time being, you don't know it. Okay, so we can cheat for the next 2 weeks. Then you will find out. But because the second part, it doesn't matter. The second part, you have to do variation of parameter. So we want to go ahead. Let's do the variation of parameter. Okay, there you are.
We'll find out where the actual thing is.
That's it. Look at this one. Given that, means you don't do it. Given that y1 is equal to the x squared and y2 is equal to the x cubed. Okay, our solutions of this equation: x squared y double prime minus 4x y prime plus 6y equal to 0, and x is positive. So it's given, so you don't have to check it. So these would be the solution of the homogeneous equation. Now they ask you, oh, find the general solution of this one. Find the general solution of this equation. What is the equation? X squared y double prime minus 4x y prime plus 6y equal to 1 over x. You see, this is another format of these problems. You know that to find the general solution, you need the YC and the YP. So they give you the Y1 and the Y2. So we've got the YC. But in order to get the YP, the only choice is variation of the parameter, because the coefficients are not constant. Okay, so this is another version. It's called Euler equation later on. And the reason is, you see, look at this one, x squared y double prime, x y prime, then the constant. And we have a method to do it, but even for that part, you can only do the first part, not the second part, okay? So make sure you understand what they are asking for. You don't have to check anything because they say given that. So you just note that you can give us the, okay, you say note that YC is equal to the C1Y1 plus C2Y2 with the given information, Y1 x squared, Y2 x cubed. So you already got the YC because it's already given to you. So what you would like to do is, you would like to find the YP. You would like to find the YP. What is going to be R of X for this YP? Any suggestion? That's it. You see, when you want to pick the R of X, the coefficient is X squared here. Make sure you divide it, because this formula can be used as usual if the coefficient of the Y double prime is 1. So make a note. It's going to be 1 over X divided by what? Divided by X squared. This is going to be 1 over X. 1 over X squared. So make sure that you use the 1 over X cubed for your R of X when you go to the formula. Any question? We did this one before. You just more, you have to find the, okay, normalize the coefficient, Y double prime. There you are. So we are going to use the variation of parameter method again. Okay, variation of the parameter. Can be used. Okay, so your YP now is going to be what? It's going to be U1 Y1 plus U2 Y2. You know the formula, so go ahead. Find the Ratsgian. Okay, so there you are. y1 is x squared. You need to find the y prime because of the Wronskian. 2x. y2 is x cubed. You have to find the y2 prime, 3x squared. Get the Wronskian. So the Wronskian would be what? y1, y2 prime, y1 prime, y2, x squared times 3x squared minus y1 prime 2x, y2 x cubed. Simplify. So W, the Wronskian, is what? 3x to the 4th minus 2x to the 4th. Okay, which is going to be equal to x to the 4th. Remember, you have the restriction that the x is never 0, so we are safe. Okay, we are safe that this is not equal to the 0, of course. Okay. So go to the formula. Get the u1. What is u1? u1 equal to integral of negative y2 r of x divided by the Wronskian dx. Substitute. Oh, I'm sorry. Substitute for this one. Okay, substitute. Your y2 is x cubed, so this is going to be negative x cubed. Rx, what is the Rx? Is 1 over x cubed. You see? If you miss, divide it by, your solution will be quite different. And the Wronskian is x to the 4th. So the top one, the x cube and x cube would cancel out. We get negative 1 over x to the 4th dx. Okay.
That would be the natural log of x to the negative 4th, right?
No, 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 no. I just make sure I didn't miss anything. So this is the x cube. So we get the, yeah, that's good. The case. No, no, you move it up. Yeah, you move it up. It's a negative x to the negative 4. So it's going to be what? Negative x to the negative 3 over negative 3. Okay, that's going to be the case. So this is, yeah, that's fine. That's fine. Okay, so so it's going to be negative 1. It's going to be positive 1 over 3x cubed. Okay, so this is going to be your U1. Any question? So we just like the problem at the beginning. Okay, so go back to the U2. U2 is going to be y1 r of x Wronskian dx. Substitute. I just simplify 1 over 3x cubed. Okay. So let's see what would be the U2. Y1 is x squared. So that's a 1 over x cubed. Then divided by Wronskian, x to the 4th dx. If you simplify it, there is going to be 1x out here, so that you 1 over x to the 5th dx. Okay, it's x squared over 1 over x cubed inside the integral. I simplify it. There's going to be leftover of 1x down the denominator, so it's going to be 1 over x to the 5th. So you move it up, x to the negative 5 dx. So that gives x to the negative 4 over negative 4. So that would be 1 over 4x to the 4th. So U1 is 1 over 3x cubed. U2 is 1 over 4x to the 4th. Yes. Negative, yes, you are right. Negative. Negative. Negative one over x to the fourth. Okay? Are you done? Ready? We are not done, of course. You have to get the YP. Okay? So remember YP is U1, Y1, U2, Y2. Let's multiply them together. So I post this note there later so you can check it if you want. So get the YP. YP is U1, Y1 plus U2, Y2. Substitute. What's U1? U1 is 1 over x cubed, 1 over 3x cubed. And you take the y1 to be equal to the x squared. So we simplify it. So that will give us 1 over 3x. Remember, no constant c is a particular solution. So that would be, oh, I'm sorry, I forgot to. I have to continue. Plus, sorry, let me just continue. Plus y2, I write it on here. It's too much. Plus u2. What's a u2? Negative 1 over 4 x to the 4 times y2 x cubed. Simplify. What's going to be the result?
1 over 3x minus 1 over 4.
1 over 3x minus 1 over 4x. That is the YP. The final answer, YC plus YP. And then,
to simplify the YP, the 1 over 12?
no,
No?
not the variance. Okay, that's going to be YP. Okay, so there are going to be a couple of, this one of them that if you pick the tangent over there, it takes some time, but we have it. So we are ready to go over that practice grid on ready.